Hello again. We're going to now have a talk through of this PowerPoint using moles to balance equations. This goes hand in hand with the finding reacting ratios handout that should be attached. It's 2 pages, this handout, so make sure you print off both. And we need our trusty periodic table. So this is higher tier only, and we're going to use moles to write balanced equations when we've been given the masses of reactants and products. So just very quickly, you might not have a person next to you to explain this to, but have a think. What does this equation tell us? What do we know about this? What it should tell us in words is, in this reaction, a certain number of moles of magnesium and a certain number of moles of hydrochloric acid react together to form a certain number of moles of magnesium chloride and a certain number of moles of hydrogen gas. And those moles are hopefully you've been able to work out. If it's not got a number in front of it, it's 1 mole. If there's a large number in front of it, it's 2 moles. The big numbers in front of the formula, a number of moles. These little numbers within the formula, they are the number of atoms in each element of the formula. Okay, so last lesson we did this. We used balance equations to work out masses of reactants needed and masses of products formed. But we can also do that in reverse. We can use masses of reactants and products to work out a balanced symbol equation. There is a method that we're going to do, and you can draw it out neatly in a table, which I'll show you later. This is a step-by-step method. Number 1, divide the mass of each substance by its relative formula mass to find the number of moles. We know what that is. That's our little formula triangle, N equals small m over mr. Then we're going to divide the number of moles in each substance to find the smallest number of moles in the reaction. And then if any of those numbers aren't whole numbers, we might multiply it all by the same amount so they become whole numbers, and then we can work out our balanced symbol equation. Now that seems wordy now, and we'll come back to it when we've had a bit of practicing, okay? So coming to your handout here, finding reacting ratios. So I've put that on the PowerPoint as well, so it can go hand in hand. The first one is done for you as an example, but then I'm going to talk through the second one as well, and I want you to do 3 and 4 on your own, okay? So, to start off with, the question says, in each of the following, find the molar ratio in which the substances react. We're actually only going to do the left-hand side of our equation. 140 grams of nitrogen, N2, reacts with 30 grams of hydrogen, H2, to form ammonia. Now you don't need to worry about the chemical formula for ammonia, because in this particular question we're only going to work out the left hand side of the equation. They're not actually asking you to calculate anything about ammonia, they just want to know what ratio the substance reacts in. So to start with, we calculate our moles. The mass has been given to us, 140. From our periodic table, you can see that nitrogen here has got a mass of 14, focus, but because it's N2, the formula mass is 28. So we've got mass over molar mass, 140 over 28 gives us 5 moles. Now we're going to work out the moles of hydrogen. The information up here tells us it's 30 grams, it's H2, so the formula mass is 2. So it's 30 divided by 2 gives us 15 moles. So now we write out our ratio. N2 to H2, it's reacted 5 to 15. To work out the smallest ratio of reaction, you divide by the smallest number. So if I divide 5 by 5, I get 1, and if I divide 15 by 5, I get 3. So therefore, I know that my ratio of reaction is 1 mole of nitrogen will react with 3 moles of hydrogen. And we know it forms ammonia, but we've not been asked to calculate that section. Okay, So what I've drawn out here is a table to help you keep track of your calculations, because while it's quite easy if you're only calculating one side of the reaction, when you start to calculate the whole reaction, you need to keep track of your calculations. So I would encourage you to write this out like this for each of these calculations. So this is number 2 on our worksheet, number 2 here, number 2 here. 5.8 grams of butane, C4H10, reacts with 20.8 grams of oxygen, O2, during complete combustion. So again, we're just working out the ratio of the chemicals that react. So we've got our substance here, C4H10 and O2. The mass has been given to us, 5.8 grams of our butane, 20.8 grams of our oxygen. Using our periodic table, we're going to calculate our MR. Carbon, where are you? There you are. Carbon 12, but there's going to be 4 of those, plus 10 hydrogens, which give us a molar mass of 58. Oxygen is 16, but its formula mass is O2, so we times 16 by 2 to get 32. Now we're going to work out what our moles are. So moles, as we know, is mass over MR. 5.8 divided by 58 gives us 0.1. 20.8 divided by 32 gives us 0.65. So we divide by the smallest number of moles. 0.1 divided by 0.1 gives us 1. 0.65 divided by 0.1 gives us 6.5. Now this is not a whole number. You can't really have 6.5 moles in a balanced equation. We don't tend to do halves. Okay, so we have to multiply up by a factor to get each as a whole number. So to make a 0.5, to make a half into a whole, we're going to multiply by 2 in this instant. Okay, so we're going to multiply both numbers by 2 to give us a ratio of 2 to 13. 6.5 times 2 is 13, 1 times 2 is 2. So then we rewrite out our balanced equation as we know it to start. Therefore, 2 moles of butane react with 13 moles of oxygen. Okay, so I would like you now to have a go at calculating these ratios on your sheet. So pause the video and have a go at that. All right, you've had a go at that. So hopefully you will email me your answers. And we are going to attempt the slightly harder calculation. So hopefully you've printed off the second sheet of your calculations for ratios, and we're coming in at number 5. So in each of the following, find the molar ratio in all the substances in the equation to determine the balance equation for the whole reaction. So now you're going to work out the stuff on the left, the reactants of the arrow, and on the right. So we're going to do the same thing. We're going to draw a little table. Okay, what's our substance? Here that was going to be our reactants, and it's decomposing to form these two. Okay, so the mass was given in the question, 0.920, 0.773 and 0.147. The molar mass, just do that, we can work out, the molar mass we should be able to work out from our periodic table. 276 here, our silver oxide 232 and our carbon dioxide 44. Then going to calculate our moles of silver carbonate. 0.920 divided by 276 gives us 0.0033. Our moles of silver oxide, 0.773 divided by 232 gives us 0.0033. And our moles of carbon dioxide, 0.417 divided by 44 gives us 0.0033. Now this is very nicely shown us that if we divide all of those by the smallest number of moles, it will give us all 1. So the actual ratio of reacting in this, or decomposition, is 1 to 1 to 1. Okay, 1 mole of silver carbonate will decompose to form 1 mole of silver oxide and 1 mole of carbon dioxide. All right, so now using that same method, draw a table out, keep it really clear, keep it all in line so you can work out what is relating to what. Have a go at number 6 and 7, And then on this PowerPoint, when you've done those, email me the answers, I'll check them through. On this PowerPoint, there are plenty more examples, okay, showing you how to draw it out if you got a bit confused there, okay? And again, as ever, email me if you've got any problems, and I will see if I can help you. All right, bye-bye.